Bismillahirrahmanirrahim. Assalamualaikum. In this video, we will look into a chapter subroutine. In this video, we will try to understand the difference between the conventional branch, subroutine, and interrupt as well. Okay. Okay. Let's look into the flowchart. Here, main program. Here is the flowchart for main program, or we can say also as a routine program. Main program, we can also call it as a routine program. And for a routine program, it starts when we turn on our system. When we give power to our system, this main program or routine program will start to execute. And to write the process, we need to begin with start, followed by the initialization and process until the end of the system, meaning that we turn off our system. Okay, here inside this main program or the routine program, we will see the subroutine program. Subroutine program is a part of the main program, meaning that it is a subset of the main program. It has a one sub program. In this case, I label as subroutine S1. Subroutine S1 will have its own process, sub process. Let's begin with just sub process 1, 2, 3, 4 until the end. And after microP finish execute the subroutine program, subroutine will return back to main program. Here is the flow. When the subroutine program is began, microP will go to the subroutine program and start execute a subroutine program, line by line by line until the end. After finish execute the subroutine program, we will instruct microP to return back to the main program. This is for subroutine program. And for branch, as we already know, for branch, it go to the from main program, it will branch to also to the main program, and there is no such a return process like a subroutine. Like here in this flowchart, we check the system. If the system is ready, and then we follow the next instruction. But if the system is not yet ready, we instruct the microP to take a branch to execute this subroutine, or we can instruct the microP to execute next instruction. Okay, like this one. For looping, we do a looping, and then this looping ASRS instruction will be looping for 3 times using instruction branch with a condition in this case. Okay, maybe we can use branch if equal to 0, or branch is carry clear or carry set. It depend on our requirement. Okay, but for subroutine, we can call it a sub of the main program. Here, subroutine S2. Subroutine S2, we will have another program like this. Another sub program like this one, but maybe it serves a different purpose. Okay. Okay, that's the difference between the branch and the subroutine. Next is the interrupt. So what is interrupt? Interrupt is any events that happen outside from the main program. Like here on my window, I run a normal Windows routine. I open window, and next I open this Visio, Microsoft Visio, and this is the example of interrupt. I press Ctrl Alternate Delete. microP will execute interrupt service routine. They call it interrupt service routine. And after I finish with this interrupt service routine, it will come back to the main program, to the main program here. Meaning that interrupt can happen at any time. Maybe when micro P execute here, or here, or here, or here. So that's why interrupt, we cannot write an interrupt just like we write a subroutine, because subroutine is specific. Here, like this one on my example, I want to execute subroutine, or I want to call the subroutine at this point and at this point. And the same subroutine we can call more than one time. Maybe we can call up to 5, 10, 100 or 1,000 times. It depends on the requirements lah. Okay, but for interrupt can happen at any time. I did mention about this on our class last 4 or 5 months ago. Okay, for interrupt, it also got a program like this. But this is we call the subroutine program. But for interrupt, we call it as a interrupt service routine program, ISR program. When interrupt is being called by the system, micro P will start execute this interrupt. Okay, for your information, Cortex M0 Plus have more than 10 interrupt, like this one. It starts with the a reset vector interrupt, meaning that when we turn on the system, we call that our PC has been interrupted. Or when we press the reset button, when our system is running and suddenly we press a button reset, and this interrupt, a reset interrupt, will be execute, or NMI, non-maskable interrupt, or hardware faulty, or supervisory call, and another interrupt. Okay, so when micro P call the interrupt, or the interrupt happen, micro P will execute ISR program, starting with the initialization, sub process again and again and again, and last with return back to the main program. The difference between the subroutine and interrupt service routine, subroutine program will return to here, because we know where the subroutine, when the subroutine is called by the main program, and we must make sure that subroutine program will return back to execute next program at the main program. Okay, next instruction at the main program. But for interrupt, since I mentioned to you just now, interrupt can happen at any time. Maybe when micro P execute here, 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 or here. So micro P need to know where to return. Okay, so let's say interrupt happen here. If when the micro P run this program, interrupt happen at this point, micro P will jump to the interrupt service routine program, and after finish execute the interrupt service routine program, micro P will be written back to execute next instruction after this, the previous instruction that micro P already execute the main program. That's one case. Second case, if interrupt happen here, when micro P finish start the system, run the initialization, and suddenly interrupt happen. Either interrupt happen when a user press the interrupt button, or will reset the system, or supervisory call instruction. Micro P will jump from right from initialization. Micro P will jump to run the ISR program, interrupt service routine program. After finish, micro P will return back to execute next instruction after the initialization. Okay, so micro P must know exactly where to return. Okay, so that's the difference between the branch, between the subroutine, and between the interrupt service routine. Okay, again, uh, branch is a free branch. We can branch to anywhere that we like without any intention to return to any program, because a branch normally happen inside the main program or inside the subroutine program. But for subroutine will go to execute a new set of program, and it will return back to the main program. Remember, subroutine is a sub program for the main program, whereby the interrupt service routine is a completely a different program to handle a specific task when a special thing happen on our system. Like what? Like a reset, like a hardware fault, or timer reminder. Like on our handphone, let's say we set our handphone to ring alarm at 5 a.m. so that even though our handphone go to sleep mode, but the internal interrupt system will keep looking or keep update the current time, and when the actual time at 5 a.m. happen, the system will alert our handphone to ring the alarm.